Morning. It's interesting, this is a really big room. So what happens normally when you have a room that outsizes the crowd, then you get a uniform distribution of the people over the seats, right? And this happens naturally, and that's fine. But this room is too big. So now you all got me wondering whether the distributional properties of the crowd are different if the room like vastly outsizes the crowd. Maybe that should be the topic of a next talk sometime. So in any case, welcome. I'm Friso, and I'm here to talk about, well, pragmatic microservices for organizational scalability. So in my head, that sounded really nice when they asked me for the title and the abstract, which, as you know, for conferences like these is months ago. And then when you start to actually prepare the talk, which is obviously hours ago, then you look at that again. And I say, okay, that's interesting. Because this is a fun thing about the GOTO conferences that, you know, as a careful observer, you may have noticed, and maybe even as a not so careful observer, that basically the GOTO conference is like a traveling circus of a core team of speakers who are always there. And then when they do a conference, they amend that with a couple of local people. So the nice property about that is that if you go to the talks by the local people, you get really fresh material. So I hope you enjoy. I'm the CTO at FashionTrade. FashionTrade, I'll talk a little bit about that later. CTO, as you all know, in startups means that you know, if you think it's interesting and you want to be perhaps joining that company, then that's the person to talk to. That's what it stands for. It's not an acronym for anything. I'm also the proud owner of my 3-character Twitter handle. It was at the time when I got that, the last remaining 3-character one. And yes, I wrote a script to figure that out. The fact that it starts with an F, like my first name, is pure coincidence. Also on LinkedIn, I have 22 endorsements for awesomeness. This is a challenge to you all. FashionTrade is a startup here in Amsterdam. We are working on a business-to-business fashion wholesale platform. In essence, that means that if you have a clothing store and you need to buy clothing from brands, like Levi's or something like that, you can do that through FashionTrade. And then our marketing department calls that simplifying wholesale so you can connect, trade, and grow. This talk is not a lot about what FashionTrade does as a business. Just to give you an impression nonetheless, it looks a lot like e-commerce, because obviously it is e-commerce. So then, because we're a fashion company, we have a couple of attributes that perhaps require some explanation. First of all, this is the fridge that we have in the office. And this is the first company that I've ever joined that has a fridge that dresses better than me, in spite of the fact that I'm even wearing my cloud shirt today. Also, because of our esteemed marketing department, I have a slide template for all of the decks that I'm supposed to use that, as you noticed on the title slide, brings more emphasis to the company logo than to the title of the presentation. So, to fix that, I'll put it there again. Pragmatic microservices for organizational scalability. So pragmatism, whether or not strictly defined, is something that we can probably all wrap our heads around. And it has a lot to do with getting things done, and then you can get more formal about it, but I don't think for the purpose of either this talk or our lives, it's really important to get to the bottom of what pragmatism is. Organizational scalability, however, is trickier. So what does that mean? You know, mostly when you look at startups and you're going through a particular growth, then especially from the outside, you know, it usually looks a lot like this. right? All of a sudden, the company attracts a certain amount of funding, and then usually on the order of 2 to 6 weeks later, the recruiters are all over the place. And all the compensation goes up, and the perks become more interesting, and the lunches get better, and the foosball tables get bigger, and all of these things. So then you hire more people, because who doesn't want better lunches? And you provide the people with a brand new MacBook Pro, which gives them all kinds of complicated issues when they do a conference talk, because nobody has a USB-C connector anywhere. And then something happens, and all of a sudden you have this organization that's able to churn out more features, right? Because that was the point of scaling the organization. So that looks good, right? We can do this. Because we're all software developers or engineers, or whichever parlance attracts you. So we're clever people, and we'll figure out the thing in the middle, right? So that's what you do. So this is the actual growth of the development team at FashionTrade over the past year. I don't know if you can read the scale. It's actually pretty big if I look at that screen. But this is roughly a year, and the title of the chart says active team members per week. So that means that in any given week, this is the number of people that contributed code based on our Git commits. So you see it also goes down sometimes, because first of all, people leave, not people that we've hired, but we've worked with quite a bunch of contractors to bootstrap the company. So it's natural that they leave in favor of our own hires. And then also there's this dip for some long period of time, somewhere at the end of end of last year, beginning of this year, and that's probably right about the time when the team reached the threshold in size where the CTO doesn't commit code anymore afterwards. Sorry for that. So it goes up and down a bit over time, but in the end, yeah, the team grows. So in order to reach our organizational scalability targets, I've personally said, well, there's two things that are really important to me. First of all, if you're hiring and you intend on keeping on doing that for quite a while, then there's a huge benefit in getting new people on the team productively very fast. And that makes sense, right? Because as soon as somebody becomes productive on the code base, it means that also at that point there's less interference with the rest of the team in terms of figuring out how things work and getting up and running. Yeah. And then secondly, I said, well, as the team gets bigger, then we need to collectively be more productive. We need to be able to produce more. Yeah. So the sign, that's the proportionality. It's a bit weird here because we're using the PDF version of the slides instead of the ones in Google Slides that look really slick and just well done. So I didn't really want to put emphasis on the proportionality sign. It's just supposed to be in one line. So development productivity should be proportional to the team size, and that's good. Right? Because it's simple, and we can keep simple metrics. Because if you think about organizational scalability and you look at perhaps guidelines that are out there about achieving that and what you need to do to achieve that, it will usually come in along the lines of 200 pages with at least 2 or 3 dozen things that you need to get right in order to make everything work. And then as a result, it's very easy to go into the trap of keeping track on all of those individual things that you should make work according to the book without ever looking at whether your organization as a result is actually scalable. So simple metrics are good. Fast onboarding of a new developer, what does that mean? Well, for us, it's simple. We want to get somebody productive in 1 to 2 days. So on your second day at FashionTrade is the latest that you should have made a useful production commit. So something that was actually deployed. So we set about how do we go and do this, and obviously we said, well, we'll use microservices because that's supposed to work for organizational scalability. And then when you look at microservices and microservice architectures, then obviously, as I just mentioned, you have these, the books that tell you if you want to do microservices correctly, you have to do all of these things. And one for one, all of them make sense in particular contexts and for particular reasons. But still, remember that there's a trap that when you start doing all of those things, you may lose track of whether they're actually solving your problem. So whether they actually solve our problems is something we'll get to at the end of the talk. But before that, I'll dive into how we set up our architecture and how microservices are, and et cetera, et cetera. Because I know I'll use microservices, but then, right, there's quite a couple of things that we actually need to take care of before that even remotely starts to work. And I enumerated that list here because these are kind of all individual things that somehow tie together and make up your platform as a deployment platform, as a target infrastructure basically to work on. Of course you need to automate all the deployments, right? But we already did that anyway. Yet it's a bit different, and I'll tell you a little bit about it later. Yes, you want centralized logging, you want centralized monitoring for metrics, but also you need to care about centralized authentication all of a sudden. Because if you have 25 different services running somewhere, they need to have the same concept of a user and a role, in which there are. If you have those 25 different services running somewhere, then from the outside, it still has to look like one thing. It needs to be FashionTrade.com in our case. So API routing is a real concern. It's not necessarily solved to satisfaction by some of the more popular either hosted or open source solutions that are out there. And then if there are services, then those services need to have some kind of inter-service communication, both synchronous and asynchronous. And that's apparently hard. So the essence of having this list, and we'll get to that later again, is, but you have to realize that if you want to actually say, I know, we'll use the microservices, then you have to be prepared to do all of those things. Because there's not really a shortcut. And there's not really something that you can leave out here in order to make it work in a production setting. There's no light version of this, for as far as I've been able to discern. So, the deployment, as I said, it was always automated. Why is it harder now? Remember the days when you could just build the artifacts and SCPs over to some machine that was the server, and then you would maybe reload or restart there, and it would work. And that process is very simple, right? So you build the deployment artifact, and you move it to the target environment, and there you start it, and it runs. And those are simple steps. And then we said we need to automate that, and we need to keep the environments, we need to keep those consistent. So we're not going to build it on the local developer machine, we're going to build it on a build server. And then from there, it's going to move in an automated way to our subsequent, acceptance, production, whatever environments we have. But that's hard with our services, because there are easily like more than 20, 25 technologies involved in just getting something to run in production anyway. And obviously there are multiple target environments for the service. And we deploy to Kubernetes, and the Kubernetes primitives are way too low level for getting started quickly. So if I get somebody new on the team and I have to explain them what a deployment and an ingress is, and then what a service is as opposed to a pod or a container, before they can do something useful, then I won't hit that target, right? I won't hit that simple metric. I'm not going to get somebody to deploy something to production on their first or second day, because you don't learn all of that on day one in combination with our code base, in combination with our conventions. So as a result, we describe deployments at a way higher level. Because if you're taking your Kubernetes YAMLs, the manifests, and put those with the service and make that your lingua franca for deployment, then on the first day somebody is learning Kubernetes instead of coding. So deployment is declarative as a result. I'll show you the details later. There's this other thing, right? You want to talk to another service. It's REST, simple. Everybody knows REST. But then it turns out it takes many forms, and on top of that, you can have a gazillion different ways of achieving that on the client side. And once you start doing that, how do you marry your centralized authentication into all of these? And then when this other service is there, how does it do logging as opposed to your service that you're working on? So one of the popular arguments for microservices is you can say, hey, if you want to build this thing in Python and this other thing in Java and this other thing in maybe Scala, if you want to go down that road, then you can, right? And that's really cool. But if you want to scale an organization, if you want to put a lot of new developers to work very quickly, then broadening the spectrum of languages that you'll allow or that you use will very quickly lead to reduced conventions across the board. And as a result, it becomes really hard to make people productive very quickly, because conventions make productive. And that means if all the service calls from another service look the same, then it's really easy to spot them. And then if you know that it's done in this particular way, that you don't have to worry about the authentication. So we're actually quite strong on conventions. And we don't have a lot of different languages in spite of the fact that we run this service platform. In order to make somebody productive on their first or second day, you have to hide a lot of things under the hood. And that's not even strange, right? Anybody can push something useful to Heroku more or less instantly. And internally, you want to reach that point too, in order to be able to ramp up. That means deployments need to be declarative, because actually telling Kubernetes what to do doesn't scale from an organizational point of view. You will need abstractions over common things, and you will need conventions that make things recognizable. There's a lot of principle of the least surprise in there. So this is what deployment looks like for us. When you have a service, it needs a Docker file. The Docker file, obviously, as a result of the build, will produce a container image, and that's your artifact. We deploy that to Kubernetes, and before we all start reading this entire Docker file, this is not the important one, or at least not the not exclusively important part. The important part of that file, when it comes to deployment, for us is this. This is essentially a number of labels that you put in your Docker file that will tell our infrastructure and deployment setup what to do with your service. And it has things in there like the path and DNS prefix routing. It has things in there like the port numbers that you expose on the inside and the outside. And it can have many more things in there. It can have things in there like this particular service needs the API key to the email provider available as this and this envar. And then that will happen because there is secret management happening somewhere under the hood, and that secret will be exposed to your service as an environment variable. You can also leave hints in here about the resource consumption that you expect your service to have, but whether or not the deployment pipeline actually uses that and how it uses that is not of your concern as a developer at that point. And so there's a lot of these additional things you can do. But the essence is that this is a declarative, let's say, language for deploying your service based on this metadata. And we have a tool internally built. It's called Metatron, because it's about metadata and, well, Tron, come on. And it basically abstracts away all the Kubernetes things. During the deployment pipeline, this tool runs, and it creates all of those Kubernetes YAMLs that you need to get a service up and running there. And in the meantime, it also allows us to manage the Kubernetes resource management at a different level from the actual service development. Somebody can notice that the resource consumption for a service is getting out of a particular bandwidth, and can actually fix that by at the deployment level or by redeploying, without having to make commits to the actual service. And this is nice, right? Because if an operational concern starts to result in a commit to the actual service, then that leads to some pull request contention with feature development. It has to be merged at some point again. That's nasty. And then when the service is there, you also see in this metadata that it tells you things about routing. So the gateway mapping on the bottom of the 2 lines, it has a path segment and a DNS prefix. And that basically means those 2 lines, that this particular service will be deployed on api.fashiontrade.com/PIM. PIM stands for Product Information Management. That's a fairly domain-specific concept for us. And then there's GateKit, and GateKit is our API gateway. So what GateKit does is it's going to poll the Kubernetes clusters at runtime for this same metadata that comes with the service, and update the routing state dynamically based on that. Because routing state is runtime state, right? And whenever something in a runtime happens and you need to reconfigure an HA proxy and restart it, that's usually a very brittle automation. So instead what we did is, we said this thing needs to just see what is actually there. Because if you, as part of your deployment, or reconfigure your API gateway, but then all of a sudden, for whatever reason, the rest of the deployment fails, then also this routing information will be stale. So instead, it polls, looks at the Kubernetes cluster, and then it takes care of that routing. On top of that, it also takes care of authentication, not authorization. That's a service level concern, of course, because it involves, is the user with this role allowed to do this particular action? But GateKit will basically offload the principal from the incoming request. It doesn't matter to the backend service whether that principal came in through an API key or basic authentication, not that we support it, but let's say, or a cookie that was set, which is what we actually use. So the upstream service internally can just trust a couple of headers. Let's say, hey, this request comes from a user in that role. So in the end, when you tie it all together, it looks like this. I think this thing has a laser. Cool. I've never used a laser in a presentation before. So our outside traffic comes in through Google Load Balancer. That's where we do SSL offloading as well. Then it hits our API gateway. Currently, that does authentication and service routing. Later on, that would also be the candidate for implementing things like A/B testing and rate limiting if we want that. Then the internal requests, which are already authenticated, and the gateway will also at that point already give the appropriate 401 for a request that basically is not even allowed to hit an internal service. Internal services are deployed to the Kubernetes clusters. We use 3 different persistence services. One is Google Cloud Data Store. For those not familiar with Google, it's like Dynamo, but then on Google. Then on top of that, we use Elasticsearch and we use Kafka. Because the FashionTrade, our deployment infrastructure, is obviously based on Jenkins, because it's Jenkins. I'm a big fan of boring technology, right? Jenkins looks ugly and has been around forever. So that means it must be so extremely useful that nobody had to update the UI in order to sell it. I think that's good. On top of that, we use Java, we use Python, because these are solid ecosystems and we can solve problems with them. That said, this same approach would definitely allow you to deploy any other service based on different language runtimes. The remainder of our infrastructure required for let's say control, which is deployment, but also library artifacts, container registries, all of these kinds of things. Everything except Jenkins in there is something that we have cloud hosted. So we don't run our own like npm registry for our front-end JavaScript packages or all those kind of things. They're fairly simple concerns. They're well thought out by several companies, and they provide good solutions for that. Same goes for monitoring and logging. This is outdated, this slide. We moved away from Google's internal tool called Stackdriver. We have some other solutions there now. I'll talk a bit about that later. But this is essentially the landscape that we run. What you also see here is that our authentication provider, the actual username and password management and storage, is something we don't do ourselves either. So then you get to these other concerns, right? I have a service that's deployed because I was able to write like 12 lines of Docker file. And then there's logging. So for all of our Java-based backend services, you need to add this snippet to your configuration, and it will do logging. And then you see this NFAR that is referenced there, and that comes out of the managed secrets in Kubernetes, which comes out of our entire deployment infrastructure, which you at that point don't really have to know about yet. Metrics and monitoring, similar. Our Java services are based on a framework called DropWizard. It has some nice features for metrics. And we wrote this one little plugin that everybody uses everywhere that makes sure that if you put this little snippet in your configuration, then you get metrics and monitoring on all of the service calls in your service. You don't have to do anything more than that. So here's the list of stuff we built. We built this API gateway ourselves. And I'm aware of a lot of other initiatives there and open source initiatives there and cloud-based solutions there, and yet we built it ourselves. We built Metatron, which is our translation from the declarative deployment to the actual runtime deployment, which is Kubernetes. We built custom Swagger code generation templates to make sure that we have a consistent API across all services for client-side calls, and that they match our usage of asynchronous HTTP, and that also they match our particular idioms on how to do async code in general in Java, because there's quite some solutions there as well, and we standardize on one. We built a custom logging appender for our DropWizard setup, so centralized logging just works. And we did the same for metrics and monitoring, and also we have a fairly complex Jenkins setup, where Jenkins also runs on its dedicated Kubernetes cluster and has Dockerized build slaves and all of these things. And you don't have to manually create jobs, obviously, because when you create a new repository in Git and it ends in -service, then that thing will become a service. And it gets a build pipeline and a deploy pipeline for the different target environments. So be mindful, you actually have to do all of these things. So then there are some other things that we set up. And this is obviously where you get to the point where the organizational scalability of what you do is not only dictated by the technology that you use. We have code style guidelines and static analysis rules, and we have really extensive REST guidelines. That's a really long document. And we have some wrapper libraries that make sure that at the code level, a lot of things that we do a lot always look the same. In order to make this scale and work appropriately, the pitfall that many of the, let's say, the larger companies fall into is the insight that these things really help speed things up because everybody is on the same page. But then the oversight that you need to have like a dedicated body of governance on these things. And that's when you get like the enterprise architect or the lead architect or these kinds of things who will every now and then just for fun change the code style guidelines so everybody gets to do something else next week. Right? And that's really annoying. So you have to be conscious of the fact that all of the things that you want to make sure that are embedded by convention into the development organization are also the product of the development organization. So anything that basically dictates the way of working to any extent is formalized in Git repositories again, and the only way to change it is by creating a pull request and having it up for review amongst the rest of the team. There's nothing against wanting to change the maximum line length from, I don't know, 170 to 250, but you have to go through the review process, and that involves obviously the one who that pull request gets assigned to, but also anybody else who has an opinion, because that's why we have it there. So that's really important, right? So a lot of these decisions are the result of process and not the result of a role, right? Not the result of somebody carrying a particular role and by virtue of that being able to change things. That includes me, and I don't know what the maximum line length is. It's probably something. So then there's the things we didn't build. And this is sometimes hard to defend, right? Because people want to build these things. I want to set up an ELK cluster, because then I can say that I've set up an ELK cluster. I want to set up Prometheus, because it's this next cool thing. And I want to run our own Kubernetes cluster, and even I want to write an authentication provider. Trust me, it's really boring to write an authentication provider, and then when you see all the things that you did wrong and how to solve them, it becomes even a lot more boring. So we really defend ourselves against building these kinds of things. Google has hosted Kubernetes. It works very well. We use an hosted ELK stack. It doesn't work extremely well, but I can attest that it works. And also, the probability that it works while all of our other things are breaking is obviously a lot larger than when we would host it ourselves. Just for simple statistics, right? Regardless of whether the events are related or not. But if somebody else is managing that cluster and I'm managing my own, then the probability of both breaking at the same time is just substantially less than when I'm managing both. And that's a big benefit. And I've been in many environments that whenever shit hits the fan, the logging cluster is the first thing that breaks and you can't see anything anymore. Same with Prometheus. So we use Datadog, which is a SaaS-based monitoring and metrics solution, and it works really well for us. And then, as you may have collected from what I was saying, there was this trend of keeping things boring, more or less. So we have this stuff built in Java, and we do all the HTTP calls the same way, and we do all this the same way, and we do all that the same way. So doesn't that really defeat the purpose of having these services anyway? To an extent, yes, if you would never allow anything else. Of course, we do things in other programming languages. We have services deployed in Python as well. And I'm pretty certain that when you look a year from now, we'll have a couple of other languages in there as well. But the thing you have to keep in mind that in order to introduce a new language, you still cannot take any of the shortcuts. How do you build a container that contains the application in that language? And then how do you make it conventional and simple for somebody in that language runtime to add the centralized monitoring, to add the centralized logging, and to add the internal service calls? If we're doing Python, do we create a new Swagger code generation template for that language so that we make sure that when somebody does an internal service call, it always looks the same? Because otherwise, it's just REST again. And then you get these 500 different packages in Python that you have for doing a REST call. So you can have multiple languages, you can have multiple things. But if one Python service looks wildly different from another one in the same company, then that's going to slow you down in terms of scalability. Because people will always move to other teams and move on to other efforts. And when they get there, it's just a substantial gain when stuff looks the same. So that's all cool. And we did all of that. So is it working then? You may ask. We had these two simple goals, right? I want to do really fast onboarding. And I want to make sure that when I add people to the organization, that we'll start producing more software as a result of it. So for the onboarding, yes. So far, everybody who's joined has done their first useful production commit on their first or second day. And from that point on, it becomes apparent quickly enough how to do things because of convention, because of documentation, and because of the fact that everything looks kind of the same. Also, when you move to a different team or when you move to a different particular service to work on. And then what happens is gradually over time, people will pick up the details about how everything under the hood actually works. How our build pipeline actually works. And then the other thing, and that's more tricky, right? So did the organization scale in terms of productivity? Did we actually become, did we gain feature bandwidth, basically? Because that's what you care about. And it's a tricky question because what is productive? And this goes back to a discussion that many people had on software teams and software organizations. And how do I measure the output, reliably measure the output of a software team? So the simple things that come to mind is obviously story points. We do story point estimation for our sprint planning, and apparently it means something, so we do that. We obviously know how often we commit, how many pull requests we do, how many lines of code. Yeah, we know that, or at least we could know that. I haven't counted. If nothing else, I would say the pull requests are the most important thing here, because whenever you do a pull request in Get Master and that gets merged, then actually something gets deployed to an environment. And then when it's deployed in that environment, the person who wrote it will briefly have a look at it, and if it all looks satisfactory, they'll push a button and it gets promoted to production, and that's it. So let's have a look. First thing is the just plain number of repositories over time, right? This is the number of Git repos that we have, which could be anything, right? From documentation to one-offs, to stuff that comes out of the hackathon days. And actually, sometimes you see this little spike, and that's usually when there's been a hackathon day, because then people create these one-offs. But yeah, sure, it goes up and to the right. So we do more stuff. And sometimes it flattens off a little bit, and then it moves up again. Fine. Then if you look at the number of services over time, that's probably more interesting, because services actually are supposed to do something feature-wise within the platform. And that also goes up. In the beginning, it was more or less exponential, and then it flattened off a little bit, and then it became exponential again. And these things are actually pretty easy to explain. When you look at our feature progression, then this makes sense. We're starting to do additional new features, we gain more services. Fine. Then there's the story point thing. So this is the number of story points that went from anything to done per week according to our Jira instance. So it looks flaky at best. There's this huge spike, which either means somebody changed the process and then did a bulk update of something, or something else happened that's just hard to explain without being in the context still. So, you know, without diving into the very details of how all of this works, I think it's safe to say that story point estimation is something that's you know, really hard to reliably use as a metric. And then subsequently, if we were to use it, on average, it actually went down, the number of points we deliver per week. Why is that? Maybe we got slower. Maybe things got more complex. Maybe we're working on more complex features now. Don't know. If you look at it this way, so what you have on the horizontal axis here is the team size, and on the vertical axis is the number of samples. You know, so the team size of 10, we've had that for quite a long time. You saw that in the beginning in that chart, and so we have the most samples with a team size of 10. And if you have to judge this in any kind of way, you'd have to say, well, an organization of 10 to 11 people working on development is, you know, perhaps the most productive, and anybody you add after that doesn't really help. And that's disappointing, right? Because we did all this work, and we set up this entire microservices thing and all of that, and now adding people doesn't help. So when you see this, it's weird. So you go around the office and you talk to people and you say, hey, we're more people than we used to be. Do you think we're doing more work? And everyone says, yeah, we're doing loads of more work. Okay, that's cool. So maybe we're pushing more features, or at least more changes to production. So this is the pull requests instead of the story points. And you see here that, well, 10.11 looks great, although the variation is a lot larger than when it comes to the story point estimates. But then afterwards, it still gets worse, right? So now we're pushing less changes with more people in the team, according to this. So how does that work? Because people still say, no, we're doing more work. And it also feels that way, and it looks that way. So in all likelihood, you know, if you look at it this way, we might not be looking at the right things. Do we really have consistent estimates? Well, of course not, because the team is changing all the time. There's new people, and then we create these feature splits, right? You're with 4 people, and then all of a sudden you're with 10 people, and you're not going to be in a single stand-up with 10 people. So you do a feature split, and you split off some people to their own little teams. So that changes all the time. So story point estimation is probably the worst thing to look at, given that we've only been at it for a year with constantly changing teams. Does a pull request have a consistent average value delivered? No. Things get bigger. You have more technical changes. You have more technical debt to work away. So this changes all the time, and not everybody has equally sized commits. So there are way too many dynamics to actually do something useful with that. So instead, if you think the other way around, so what is the thing that matters, right? If you put a group of people in a company, and they need to start making software, and they need to be, each of them individually, their most productive. So regardless of personal preference about type and style of music, and particular way, shade of lighting, and whether or not they have this or this or this type of desk where you can run, walk, sleep, or crawl, I don't know. But regardless of all of that, there's 2 things, you know, in terms of scalability, that we believe really matters, and that's the relief of contention. So if I'm working on this, can I work on that without being blocked on it by something else that happens? And if I am going to do work for a full day, can I spend that full day in focus on more or less a single thing? So that actually leads to metrics that we might be able to, you know, usefully measure. What is the feature contention? And what is developer focus? So this is the result of that. What it has here on the horizontal is a number of service repositories that we have. And on the vertical, there's time. And up is more recent, and down is longer ago. And what the colors mean is that if it's green, that means on that particular day, there was a single pull request against that service, which was then merged to master and deployed, eventually went into production. If it's any other color than green, with the exception of white, obviously, it means that there were, on a single day, multiple pull requests going against a single service. And these pull requests are initiated by different people, right, or different groups of people or something like that. So that means that there's contention on that service. That means that there's basically people trying to push to the same part of your platform. And then, why that happens can have lots of reasons. Sometimes it's like a simple fix that another team needs in this thing, and you can just squeeze it through. But very often, it's either an architectural mistake where you didn't do the correct feature split, or worse than that, it's conceptually completely wrong. And then you have this one service here where that happens all the time. So that's our front end. And that's actually one single monolithic React app. So that makes sense. And that's cool, because then also this makes sense. And the front-enders are actually waiting for each other's builds more often than anybody else. So we should probably work on fixing that. So that's cool. We have something, we can look at it, and we can say this should be mostly green. And if it's not, we need to solve that. And then we have the other thing that says, is a person working on one thing at a time? So what this says, it has the people on the horizontal without the names. So they became numbers. Sorry, people. And still has the time. And there it says, if it's green, that means you committed to a single service on that day. And if it's any other color, that means you were committing to multiple services on a single day. And that's not focus. Invest a lot in the setup for microservices, because there are no shortcuts. And you can't do half of it in order to just get started. So if you can't do that, don't do it at all. When you have that architecture, it can help you scale the organization, but everything else is still a really careful consideration about the team splits and the feature splits, and really careful planning to make sure the people can work uncontended and in focus. Thank you.